recording. I'm so delighted that some of you were able to do the assignment. I saw quite a number of you in the discussion forum. I responded to half of the students who did. I'll be responding to others shortly. But I really loved your feedback about the shape of the Earth and the place of the Earth in the universe, what is in the solar system. So I saw quite a number of things. And before we move on, I would like to hear from you what you discovered during that time. So kindly mute. Okay, let me help you to mute yourself, to mute you. But I will, even though I have muted you, I'm going to leave the system open so that if you want to respond, you can respond. So let's have a quick review of what we did last time. What did you learn? What did you find out about the shape or about the movement of the Earth in the universe? Amal, you are the first this morning. You have a great day. So Amal Bushra, what do you
Good morning,
now?
teacher.
Good morning, Amal.
Teacher, on my research,
Yes.
I learned about the 8 planets.
Mm-hmm.
The 8 planets.
What did you find out about the 8 planets?
First of all, the 8 planets are Mercury,
Mm-hmm.
Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune.
Great.
Then they are divided into categories.
Mm-hmm.
The terrestrial and the Jovian.
Terrestrial, okay. Terrestrial.
Yes.
Mm-hmm.
Yes, the terrestrials are Mercury,
Mm-hmm.
Venus, Earth, and Mars.
Mm-hmm.
These 4, they are made up of rocky materials, the terrestrial ones. They don't have rings. They have very few or no moons. They are very small. Mercury is the smallest planet with the shortest orbit in the solar system. Then Venus is the hottest planet with extensive lava flows.
Okay.
Then Earth is the water system, the one that has the water system for humans to breathe. Then Mars, like in those days, it also had water, but now I think the water dried up, so there's no more water on Mars. Then the Jovian planets are Jupiter, Saturn, Uranus, and Neptune. They are divided into 2, the gas giants and the ice giants.
Mm-hmm.
The gas giants are Jupiter and Saturn.
Mm-hmm.
Then the ice giants are Uranus and Neptune. The gas giants are made up of predominantly helium and hydrogen. The ice giants contain rock, ice, and mixture of water, methane, and ammonia. Jupiter is the largest planet. Saturn is the second largest planet. Then Neptune is the outermost planet, one of the coldest. Then I also read the ORT cloud, collection of icy debris, and the age of solar system. That's what I researched.
Okay, thank you. Thank you very much, Amal. I want to summarize what you said, that, and I really am very impressed with your research. One is that it is detailed and it goes beyond simply saying that the solar system consists of planets and naming them. When I read in the chat room and in the e-learning platform, I think many of us just listed, and we are seeing that we can go a little more detailed. She's saying that the planets are divided into two, those that are rocky and those that are not. So the rocky ones, the ones that have a rocky ground, a solid ground, we are calling them the terrestrial, and Earth is one of them. So if we were to introduce Earth, we would say it is one of the terrestrial planets. And then the other planets, which are not terrestrial, are gaseous, and some have ice, and they are big. Many of them are huge. She has gone on to tell us the composition of the gases. So if I were to look at her presentation, I would give it a 3 out of a 3. It is on the high end. It has been well presented. The information is there, but she has gone to a greater detail. Amal, I'm going to ask you to type out your response and you send it in the e-learning platform where some of your colleagues can be able to access it. Thank you, Amal. I now go to Nabufu. Nabufu, what did you find out regarding our research?
The solar system in general.
The solar system in general. We had 4 questions, remember? Okay. So what did you
No,
find?
I want to first share the research I made.
Yes, first share the research. It's all right.
Okay. I found out that the solar system is the gravitational bound system of the sun and the objects that orbit it, either directly or indirectly. So for those who don't know the meaning of orbit, orbit is the curved path taken by a planet or another object as it moves around another planet, star, moon, or sun.
Okay. I agree with you entirely regarding that. When you say gravitationally bound system, gravitationally balanced system, bound or balanced, we are saying it is held by the force of gravity. I agree with you. Continue. And then the definition of the orbit being the path. It is an elliptical path that is around the object that is being orbited, that is being surrounded. Okay, let's continue.
So in the solar system, we have planets that orbit around the sun. And these planets, we have what we call the inner planets and the outer planets.
Okay.
Another name for inner planets are terrestrial planets. These are Mercury, Venus, Earth, and Mars. And when we talk about the outer planets, these are Jupiter, Saturn, Uranus, and Neptune. Another name for outer planets are called gas giant planet. The solar system.
Let me pause there a bit. We are saying,
yes,
we are saying outer and inner. And I'm using this particular diagram to show. So this is, I hope you are seeing my screen. Have I shared my screen? Are you able to see it, my friends?
Yes, teacher.
yes, teacher.
Okay.
Yes, teacher.
Great.
Yes.
So we are seeing the sun right here. These are the orbits. These rings are the orbits. Now the planets which are close to the Earth, the first 4 are the ones we are calling the inner planets. They are closest. They are closest. And then the others beyond that are the ones we are calling let me turn off the sound because let me first stop sharing. Someone last time said, you know, sir, that sound scares me. So let me just turn it off a bit so that it doesn't scare you. So this is what we are saying. So you see, these inner ones, 1, 2, 3, 4, are with Mars. So after Mars, the ones away from us are the ones we are calling the outer. That is what we mean. And she's saying the path is called the orbit. I'm pausing it. Continue, please.
Please make it big.
Continue, Nabufu.
Thank you, teacher. Before I go any further, there's another plane by which the planets move around called Ecliptic Plane, which confuses some people with the orbit.
Okay.
So the ecliptic plane is the plane of the Earth's orbit around the sun. Or it's kind of like a flat disk when you look at it.
Mm.
Well, can I share my video? Like I kind of drew it in my book.
Please do. Oh, let me give you permission. Yeah, go ahead. Okay, let me do this. Let me spotlight you. Sorry. Let me spotlight you. Okay. What are you using, a laptop or a computer?
A laptop.
Okay.
So like this is what I'm talking of.
Mhm.
If you can see that. This is the ecliptic plane. It's kind of like a flat disk.
Yes.
Yes, you can see that all those planets and the dwarf planets, if you can see that properly.
Yes, we can.
Thank you. Can we stop sharing now?
Go ahead and stop sharing.
Okay, about the ecliptic plane,
Mhm.
I said it's the plane of the Earth's orbit around the sun. And in this, I'll call it the flat disk.
Okay.
I'll call it the flat disk to make it easier. We have the planets, dwarf planets and asteroids going around the sun in this flat disk called the ecliptic plane.
And what are the asteroids? Because you are saying they are asteroids going around. Did you find out what they are?
Yeah. According to my research, I found out that asteroids are minor planets in the inner solar system. Okay. In other words, asteroids. What I mean by minor planets, they are leftovers from the formation of our solar system.
So they are objects, they are stony objects, rocky objects.
Yeah,
right?
they're like stones.
Okay, so rocky
In
objects.
formation. Yeah. They are formed when a planet and another planet collide, and that's how it's formed. Like they collide, and some pieces fall off planet. And that's why we call them minor planets.
Okay. Okay. There is, thank you. There is someone in the chat room who can't hear. Could one of you get in touch with Zachariah and ask him or her to tap the screen and join audio? Okay. Someone has asked him or her to, so Zakira Nachiganda, yes. If one of you knows how to assist, if she's using a phone, tap the screen and join audio so that the rest of us can continue. Great, thank you. So yes, Nabufu, you have done good research. You have told us about the outer planets and the inner planets. and we have demonstrated that.
Yeah.
And you have clarified the difference between an ecliptic plane and the orbit. The orbit is the path, but that path is, they form like what you said, a disk. They are along. So all of them are moving on this path. So there is one path here, another path, and another path, as you explained, and it is more or less like a flat surface, and we are calling it a disk. Thank you, Nabufu. I'm going to pick two more
Welcome,
to
Chair.
get the research and ask you to write out your responses, put them in the platform so that we can join, that we can combine them into notes. Okay, I'm going to ask Marilyn. Marilyn, you are the one to shine at this time. Marilyn.
Yes,
The opportunity.
I did. I made research of the solar system.
Mhm.
I drew the diagrams in my book.
Yes.
I realized that since Mercury is the closest planet to the Earth, like we had watched in the other video, the closer you are to the sun, the less days you take to orbit around it. So I realized that Mercury takes 88 days to orbit the sun. And there are 8 planets in the solar system. I drew the tropics of Cancer. I drew all major latitudes and longitudes for the Earth. And I tried knowing why our sun is called Sol. It is named after Sol, after the Latin word for sun, and Solis is anything related to the sun. That's why we call it the solar system. I made very little research.
And that's why we say solar panels, solar energy, solar
Yes.
system, to do with the sun. Did you also find out that the sun is just a star?
Yes, I did.
Okay, great. So let's
And
continue.
they are bigger suns than the sun itself.
They are bigger stars than the
That's-
sun.
Yeah, there are.
They
And
are
it's
bigger
moderate
stars and bigger suns.
stars,
Okay,
even hotter ones.
great. So thank you, Marilyn, for that. Finally,
Welcome.
thank you. Finally, I'm going to Nakawoya. Nakawoya, unmute. What did you find out?
Yes.
Nakawoya najua?
What is the solar system? Yeah, I researched that system is the gravitationally bound, either directly or indirectly. Of the objects that will be the sun directly, the largest are the 8 planets, with the remainder being smaller objects, the dwarf planets, and small solar system bodies.
It's not working.
Okay.
Teacher, it's not working.
And what constitutes the solar system? Our solar system constitutes of our star, the sun, and everything bound to it. By gravity, the planets Mercury, Venus, Earth, Mars, Jupiter, Saturn, Venus, and Neptune, dwarf planets such as Pluto, dozens of moons, and millions of asteroids, comets, and meteoroids. And what is Earth unique in the solar system? In the solar system, the Earth is the 3rd planet from the sun, and it is the only planet known to have life. The ability of the Earth to harbor life makes the Earth a unique planet in the solar system. And this stems from the fact that water in liquid form exits on the planet. And what is the role of the Earth in the solar system? I researched and I found out that compared with the billions of other stars in the universe, the sun is unremarkable. But for Earth and the other planets that revolve around it, the sun is a powerful center of attention. It holds the solar system together, provides life-giving light, heat, and energy to Earth, and generates space weather. And identify the positions of poles and the equator. And what I researched was the equator is the invisible line that runs around the Earth, the center of the Earth, at 0 degrees latitude. An equator is an imaginary line around the middle of a planet or other celestial body. It is halfway between the North Pole and the South Pole at 0 degrees latitude. And the other question was, describe what the Earth looks like at the poles and at the equator. The Earth is flattened at the poles and bulges at the equator due to the fact that the centrifugal forces more at the equator than at the poles. And describe the shape of the Earth through discussion. Yeah, so I've described the Earth is flattened at the poles and round at the equator, so it is a geoid. Yeah, that's what I researched about.
Okay, great. Thank you very much, Nakaoya. I have seen that you've clearly understood what the position of the Earth. I loved the statement that the sun in the case of the entire universe, it is unremarkable. Unremarkable, it is not so huge, it is ordinary. It is not that hot, they are hotter stars. It is not the farthest, they are farther ones. It is ordinary. But to us, who are just 93 million years, 93 million miles away from it, it is everything. It holds us together with its gravity. It generates energy. 99% of the energy we have on Earth is from the sun. So it's really remarkable. And if the sun is unremarkable, how about us? How powerful are we? So maybe we should revise our opinions about ourselves and realize that there are bigger bodies that are even more powerful. So thank you. I want us to move on to today so that we learn a new skill. We learn something new today. What new thing do we want to learn today? Let me start with this particular one. Number one, we want to understand how the rotation of the Earth causes day and night. By the time we leave today, we should be able to explain fully, not cram, how the rotation of the Earth causes day and night. That is our target today. How does the rotation of the Earth cause day and night? Someone will tell me the Earth rotates and then that causes day and night. Fine, but how? If I ask you to write an essay about it, how? Now, I see a few hands are raised. I'll come back to you. Let me just write your name quickly so that I don't forget. I see Asimwe. Asimwe, you can put the hand down as well, unless it is very, very urgent that the lesson would not be successful unless you mentioned it. I also see Bukenya. So I have 4 hands and as well as Rita. Okay, those 4 people, I'll come back to you unless it is extremely urgent, like you're saying this thing, if we don't say it now, the lesson will not proceed properly, like an announcement, an urgent thing. But if it is content, what we are studying about, I'll be able to come back to you. So I pause just in case it is extremely urgent. Is it extremely urgent, Karunji? Karunji? Okay, Karunji put up the hand accidentally, so I lower it. Nachitende, is it extremely urgent? Okay. Mr. Byman.
Yes.
I see Mr. Byman had put his hand up, then put it down, okay. Nachitende, is it extremely urgent? I want to move on.
Yes, teacher.
Okay, tell me.
Why is planet Uranus? Why does planet Uranus have rings?
Oh, why do they have rings? Good question. And that is Nachitende. Nachitende. Why has Uranus got rings? Good research question. We shall follow it up. Thank you, Nachitende. Okay, let's go on. Let us go on quickly. Remember to mute. Okay, so last time we agreed that the Earth is one of the planets in the universe, and we looked at what we are supposed to learn. And today we have said our key thing is to understand how the Earth's rotation causes day and night. And that is where we are going to be headed. Again, let me put in the chat room the page where I am. I don't expect you to go there right now, but just in case, you can visit that particular place. I'll walk with you, so you don't have to visit the page at this time. So just click that one. So last time we looked at the solar system. We looked at this. We saw the different planets, and you have clearly indicated to us Mercury, Venus, Earth, and Mars. And we said that the ones here are called inner planets, and then these others are called outer planets. Number two, we agreed that these other planets which are away are much bigger, and we have observed that they take longer to move around the sun. So you can see the one which is near, it quickly revolves around it, but those which are far, like you're seeing here, Neptune, it will take forever, many years of the many Earth years to just move around the sun. So that is an observation we are making. We are saying that the ones here inside are inner, the ones on this side are outer planets, according to what we now know. Then we talked about the shape of the Earth. We said that the Earth is elliptical, that it is a sphere, but not a perfect sphere. We ended up calling it an oblate spheroid. Now, when we divide the Earth, we said that it will have the longitudes and the latitudes. Longitudes are these lines stretching from the North Pole to the South Pole. Longitude, longitudes, long. I use that, long, longitude. Then we have the latitudes, latitude. So the latitudes are these imaginary lines, these ones which are horizontal. And the one in the center is referred to as the equator, this particular one, which is roughly halfway from the north and south. We call it equator. It is imaginary. Don't go looking for it on the ground. Even if at Kayabwe we say, the equator is here. Please don't go to Kayabwe and say, now I have touched the equator. We know it is there, but surely it is imaginary to us. Its forces are clear. So the assignment, we said, identify the position of the poles. You drew the diagram, describe what the Earth looks like at the poles. I saw descriptions of that. We said it is flattened at the top. Describe the shape of the Earth, we did, and we wrote some of the notes right here, an oblate spheroid. Okay, let me check the chat from here. Teacher, I can't hear you. Okay, I'm going to do a check. I think other people are able to hear. Kiddy, you've sent a comment, you can't hear. Let me just respond to Akidi quickly. And I say, Akidi, to her quickly, to ask her, please tap your phone. Tap your phone. Screen. And then do what? And connect audio. I think she needs to connect audio. Okay, let's see. Then I'm seeing a question, what is the difference between the sun? Teacher, I have some research on what will happen if the sun dies. Najinda Mason, what will happen if the sun dies? Najinda. I'll give you an opportunity towards the end for us to share what will happen. But today, let us first answer this huge question. Najinda, please, what will happen when the sun dies? I'll give you a chance. So the shape of the Earth, we looked at it as here, and the evidence to show the shape of the Earth. Then we said draw diagrams to show the shape of the Earth, and on it include the main lines of latitude and longitude. You drew that. Conduct internet research about the solar system and make notes with diagrams. Correct, you did that, I love it. And find out why it is called so. Why is the solar system called so? We have got that information and many planets. So we'll summarize that information. Please, this in the morning tomorrow, check in the platform for the summary of the discussions that you have given so that we can see that. Now, we want our discussion to move on to looking at what causes day and night. That one will be involved, will also involve the inclination of the Earth. I'm going to start by playing video one, which will help us to have that discussion. We want to answer the question, what causes, how does the rotation of the Earth cause day and night? I stop share, then I share again, confirm that sound is there, and then here I am. How does the rotation of the Earth cause day and night? We'll watch a few videos and then we'll discuss. I'll be muting at intervals and explaining a few things as we move on. Okay, here we go.
The universe includes living things, planets, stars, galaxies, dust clouds, light, and even time. The universe contains billions of galaxies, each containing millions or billions of stars. The universe is incredibly huge, traveling at the speed of light. It would take 1 lakh light years to cross our Milky Way galaxy alone. No one knows the exact size of the universe because we cannot see the edge, if there is one. All we do know is that the visible universe is at least 93 billion light years across. The Earth is the third planet from the Sun. It is the largest of the terrestrial planets in the solar system. Initially, the Earth was in a molten state. Over time, the surface of the Earth cooled and became the crust. The Earth was formed approximately 4.54 billion years ago.
In Luganda now, in Luganda, the Earth is just one of the bodies in the universe. The universe is incredibly huge. It is 93 billion light years. It means that light would travel for 93 billion years to cross. So that is how big it is. We call them light years. The distance traveled by light for a year is what we call a light year. Marilyn, what's up?
Teacher, if the universe is so huge, are there other planets apart from the ones in the solar system which are known?
Are there other planets apart from those
The ones in the solar system.
Yes, there are. There are many other planets. Other stars also have planets. Okay.
Oh,
so now mute and then we proceed. Okay.
And is the only known planet to support life. The Earth, like all other planets in the solar system, revolves around the Sun in an elliptical orbit, and it also rotates on its axis. These two motions of the Earth, that is rotation and revolution, are responsible for many phenomena on the Earth like day and night, seasons, winds, ocean currents, all these phenomena depend on rotation and revolution motions of the earth. What is rotation?
We are saying that the sun is responsible for the weather on planet Earth. And that is a result of rotation and revolution. Remember, our chapter is the Earth and its movement. Now we are saying, how does the Earth move? How does the Earth move? We are saying the movement of the Earth is responsible for the weather differences, for the climate differences, for winter, for snow, for hot temperature somewhere. How? What are those movements?
Rotation is the spinning of the earth on its axis.
I repeat this one. Please look at this.
All these phenomena depend on rotation and revolution motions of the earth. What is rotation? Rotation is the spinning of the earth on its axis. The axis is an imaginary line. Rotation is the spinning of the earth on its axis.
The earth rotates, it spins on its axis. The axis is this line. And like you have seen, it rotates, it spins, it turns on its axis. Like
Rotation is the spinning of the earth on its axis. The axis is an imaginary line which passes through the center of the earth, connecting the North Pole and the South Pole.
Great. What is the axis? The axis, this line, which we are seeing, is imaginary. It is not a physical line. So when we have the North Pole and the South Pole, the North Pole is not here at the top, no. It is not right here. There is a tilt. There is a tilt here. This axis, combined with the rotation, will be responsible for day and night, will be responsible for winter and summer. It will help us to answer the question, why on planet Earth do we have no winter in the North Pole and summer in the South Pole? How is it that at some point we have 24 hours of day and 24 hours of night? And now it will also help us to answer why we have day and night in different locations.
The earth completes one rotation within a span of 23 hours, 56 minutes, 4.09 seconds. Roughly, it is taken as 24 hours.
Great. Now I need you to get your pen to answer this question. He has said, and we shall be using it a lot, he said,
Roughly, it is taken as 24 hours.
in 24 hours, the Earth makes one complete rotation. The Earth makes a rotation in 24 hours. Look at it.
The earth completes one rotation within a span of 23 hours, 56 minutes, 4.09 seconds. Roughly, it is taken as 24 hours. The axis is tilted at an angle.
Okay, so I need you to get your pen and you write down this question, because I'm going to ask you that question many, many times. Here is my question. We have said, let me share it. Let me share the question. Let me share my question. Here is our question. This is a question that I want you to think about, arising from that video. If it takes the Earth 24 hours to rotate on its axis, how many degrees does it cover every hour? Write that question. I am pausing for you to write that question in your book because you are going to do some mathematics. How many degrees? You know the Earth is an oblate spheroid. In a layman's language, it is a sphere. If it is a sphere, how many degrees has it got? If it is a sphere, how many degrees? That is question. That is interpretation one. Great. So if it needs 24 hours to cover those many degrees, how many degrees does it cover in every hour? Write that question. I'll need an answer because that is important in determining time differences. I'm going to stop sharing at this time. Okay, let's continue. We want to answer the question. We have not answered the question which we came to answer. What causes day and night? How does the rotation of the Earth cause day and night? The question has defeated us, but we must answer it. Someone is saying it has not defeated. Let's continue. Okay, I see so many hands raised.
It's really easy.
It's easy. Okay. This person here, I'm going to ask you to unmute. There is someone here. If you are seeing this on your screen, please respond. I've sent you a message on your screen. Okay, great. Let us continue. We want to confirm, how does the rotation cause? To some people, it is very easy. To others, it may not be. So I don't take chances. Me, I don't take chances. Things can become difficult. How can I teach geography and something becomes difficult? Let's continue. What is the axis? I am going to be asking you those questions. Guys, don't take things for granted. We continue.
The axis is tilted at an angle of 23.5 degrees from the vertical. And if a line were drawn parallel to the plane of the Earth's orbit, the axis would make an angle of 66.5 degrees to this line.
Exactly. Guys, we are saying here, the axis is tilted at an angle of 23.5 degrees from this one. So this is the axis. If there's a vertical, the axis is 23.5.
The Earth's orbit, the axis would make an angle of 66.5 degrees to this line.
Okay. And now if you look at this from here to here, that would be 90 degrees. So this is 23.5. 90 minus 23.5, you remain with 66. That's why you have this.
What are the characteristics of rotation of the Earth? Well, the Earth completes one rotation from west to east on its axis in 23 hours, 56 minutes, 4.09 seconds, which is always tilted in the same direction, that is towards the pole star as it moves around the sun. The speed of movement at equator is 1,660 kilometers per hour. The speed decreases towards the poles. The angle at which the Earth is tilted is known as the inclination of the Earth's axis.
Okay. Thank you. I see some people in the chat room are saying, you know, the Earth if it is covering, it will cover so many degrees. We'll come back to that because it's important in telling the time of the day. So let me go to the next one quickly. So how about day and night? Let's look at it. So we've seen it takes 24 hours to rotate around the sun. Oh, stop share. We've seen it takes 24 hours to rotate on its axis. That was a mistake when I said it's around the sun, on its axis. It takes 24 hours to rotate on its axis. Covering that will be 360 degrees. Someone has told me here in the chat room, but I'll give you a chance later. How does that then bring about day and night? This is what we are now answering. How does that bring about day and night from that research?
What causes the repeating pattern?
Hey, wait a minute. Just a moment. Could be this one. Just a moment, please.